In this demo, I will demonstrate the online mode of DICE-Frontend. The left side configuration panel is used to configure the application. The slider allows you to change the sampling rate for each of the queries. Below the slider is a radio button where you can choose different algorithms. We will be comparing DICE with no speculation algorithm in this video. Below the radio button is a text area where we can specify dimensions for the cube. As new dimensions are added or removed from the dimensions list, cube lattice corresponding to the dimensions is dynamically computed and is being rendered in the lattice explorer below. The lattice explorer below shows the overall valid cube lattice which respects the dimensional hierarchies. Hovering over a region in the lattice will highlight the region as well as its corresponding neighbors. The highlighted point in the lattice shows the current view that the user is analyzing. The top right panel is an interactive editor which executes a query in two different modes, which is a manual mode and a dynamic traversal mode. And there are also labels which tells the overall execution time, the cache hit rate, and the status information of the previously executed query. Now, if we click on the execute button, the current query will be executed with the selected algorithm and the results will be displayed in the viewer below. The viewer shows the output of the currently executed query with the y-axis representing the measure and the x-axis the grouping dimension. Now if you see the overall time for this query, that is 868 ms, is primarily dominated by the backend execution with a hit rate of 0% since we are not speculating anything. Now let's try the traversal mode, wherein the system suggests all possible traversals for this current view. Now let's explore the parent traversal, which is a rollup. Interesting point to note here is that the results appeared immediately, followed by the error rate, which shrunk each data points into a smaller size. The overall execution time for this query is over a second with a 0% hit rate since we are not speculating anything. Now let's make another traversal. This time we'll make a child traversal, that is a drill down on zone. As we can observe again, the initial data points appeared as a large circle followed by the error bars which shrunk the circle into a smaller size. The overall execution for this query is also over a second with a 0% expected hit rate. Before switching to DICE algorithm, let's make one final sibling traversal for the no-spec algorithm and then observe the results. As we can see, all the traversals under no-spec took over a second with 0% hit rate since we are not speculating anything for the no-spec. Now let's switch to DICE experiment and see how it compares with no speculation. Let's choose DICE experiment from the radio button and then we'll start up with the same query as we did with the no speculation. The execution took around 1 second with a 0% hit rate because the cache was initially cold. Let's make the same traversal as we did for no speculation, which start up from the parent traversal with the zone. Execution time of this query is almost half that of the no spec since the previous query executed and cached the result of this query. Now let's do the second traversal, which is the child or the drill down on zone. Now the execution time was almost 1/3 of that of no spec and with a 100% hit rate since the previous query exactly speculated this. Now let's make the final sibling traversal. Again we got a 100% hit rate with the execution time almost 1/4 that of no spec.